speaker view. So when I'm talking, my face is nice and big on the screen so you can see everything. So in the top right corner where it says speaker view, hit that button so I come up big on the screen. We're gonna start with some physiometry. Does anyone know what physiometry is? We did this a week ago.
No. Yes.
All right. Well, physiometry is when we make vocab words with our body. So we're going to review our vocabulary from a couple weeks ago. So we have a point, line segment, line, ray, and angles. And we have three different types of angles. We have a right angle, acute angle, and obtuse angle. So what I need you to do is right now is just stand up, and we're going to make each of those vocab words with our bodies. All right, so remember our first one, what was our symbol for point? Who can show me? Remember what a point is? Or how we show it with our bodies? Just do a fist straight out. Does that look like a point? So that's just any location. We can put a point up here, put a point right here, we're gonna put it straight out. That's a point. The next one was our line segment. Remember, line segments have two endpoints. So with our fists, we're going to make two endpoints and go straight out. So that's our line segment. Okay, two endpoints. Christian, you're in a little tight spot there. All right, great. So the next one is our line. Who can tell me what's different from a line segment and a line? What's the difference? A line segment has two endpoints, but what's different about a line, Marwan?
A line doesn't have endpoints.
A line does not have endpoints and it goes straight down.
Awesome, you guys got it. So instead of doing points for our line, we're gonna point our fingers out to show arrows. So same thing, a line goes out and our fingers are extended to show that the line keeps going forever. Marwan, where are you going? Come back. Thank you. All right, so that's our line. Big thing is our fingers are out to show it keeps going on. Our next one was a ray. What's different about a ray than a line or a line segment? What does the ray have?
It has a
Lisa, you gotta unmute yourself. Looks like you're gonna say.
one arrow on one side, and the other one just has a dot.
Yeah, and the other one's an endpoint. So we're gonna put our point right in our middle of our chest. And then the other direction is our line extending. So we have one endpoint and one arrow, and that's how we represent a ray. Can you show me that, Christian? Show me a ray with your body. Endpoint, arrow. Show me. All right. And the last one that we talked about was our different angles. The first type of angle is a right angle. Who remembers what a right angle looks like? Remember, it's just right. So we have one going straight up and one going straight out. And this is the type of angle that we can make a little box in the corner, and that's our right angle. Does anyone know how many degrees a right angle measures?
Our head is the box.
Yep, our head is like the box, so we go straight up and straight out. Who knows how much on right angle measures? How many degrees?
90 degrees angle.
90. It measures 90 degrees. If we have an angle smaller than that, 90-degree angle, if we have an angle smaller than that, what type of angle is it? Smaller than a right angle, we have a little
Cute.
acute. Yep. So physiometry, we're going to go smaller. That's an acute angle. What about when we have an angle that's bigger than 90 degrees? What's that called, Brian? Remember, think of big is.
Big is, yeah, hold up. Big is
We have right.
more than 90 degrees.
Yep. And what is the name of that angle?
Obtuse.
Obtuse. You got it, Shalia. Show me an obtuse angle. So this would be a right, acute, and obtuse is bigger. And then Shalia, I saw her do it. She came up with a new one that we didn't add yet. But for physiometry, when we show perpendicular lines or intersecting lines, remember, what are intersecting lines? Two lines that
go across.
cross. So for maybe for intersecting lines, we can do this. Shows two lines that intersect. Nice. All right. We're going to go over today's target real quick. Can everyone see the target nice and big?
Who wants to read the target? Marwan, I see your hands up. Go ahead.
All right, go ahead. I'll point.
I
I
can
can
identify and measure angles as terms and
recognize
recognize them in
various
various
contexts. Good. So last week we looked at something like this. This is where I want you to draw on your paper now. Right? As big as you can. Draw a nice big circle. Go ahead and do that on your paper.
Okay. A big one too?
Yep, a nice big circle. Just like mine. Right now we have one whole circle. And what happens if we cut that circle right down the middle? How many pieces do we have now?
2.
2. So what do we call that in fractional units?
1/2.
Yeah, we have halves. Okay, so we split our circle one way to start, and now we're going to split it again through the middle the other way. So we started with halves, we split it again. What do we have now?
Now we have 1/4.
We have fourths. Okay?
One
We took
fourth.
one whole circle and split it into 4 parts. Right? We have fourths. So I'm going to leave that right there on your paper for now. We're going to come back to that in just a minute. Remember last week we looked at, or we created this diagram, right?
Yeah.
This diagram shows that we broke a circle up into what's called degrees. Who remembers how many total degrees are in a full circle?
Guys, remember back to our virtual field trip? Remember when we went in a 360 view and we were able to see the whole place?
Yeah.
Yep, so how many degrees are in a full circle?
0 and 90.
Well, 0 to 90 is only 1/4 of the circle. What about if we go all the way around a circle? How many
10,
degrees are we
20,
going?
30, 40, 50, 60, 70, 80, 90.
It's over on this side.
Oh, 30, 360 degrees.
Right, so in this full circle, we have 360 degrees, okay? We're gonna look at a different example today. I also showed you this tool, which is called a protractor. So that's another tool that shows that this whole circle is split up starting at 0. And when you count all the way around the circle, you end up with 360. We're gonna use another tool today to show terms as related to angles. So what is this a picture of or a diagram of? What's up on the screen?
It's a clock.
Yeah, it's a clock, right? It's a clock, only it doesn't have hands on it yet. What shape is this clock? What shape is it in?
Is it a
It's in a
triangle?
circle. A
Yeah,
circle.
it's a circle. So if we can also say that this clock has 360 degrees in it, okay, because it's a circle. We're going to look at how we can move the hands to identify our benchmark numbers. So looking back at our circle we drew up here, does anyone recall the benchmarks we use to help us identify types of angles? We know that a whole circle has 360 degrees. But if we're just going from this starting point to the top, how many degrees was that?
360 degrees.
We're just going 1/4 of the way around. If we went all the way around, it'd be 360. We're just going 1/4.
90.
Yeah, so 1/4 turn around, the circle would be 90 degrees. Does this quarter look the same or different than this quarter?
They're both different.
Are you sure? They look
No.
pretty identical to me,
Yeah.
right? Because remember, we split them up perfectly in half. So this quarter is actually the same exact distance around the circle as the first quarter. So from here to here is 90 degrees. What do you think from here to here is? From this top marker down here.
Well,
If from here to here is 90, how many degrees is it from here to here?
what?
100 degrees.
Brian, if you got, I can't hear you. You're on mute. You're on mute. Like we said, from here's 0, and we can count up by tens to get to 90. These are smaller benchmarks. We're looking for bigger benchmarks. 60, 70, 80, and 90. So there's 90 degrees from here. This is the exact same size. So how many degrees are going to be from 90 to this point?
Ryan, what do you think? Unmute yourself.
It's the same, right? We already said it's the same. So if this is 90 degrees, how much is this?
Alicia, you think you got it? It's the same exact angle. So if it's the same angle, how many degrees is it? From 90 to that next one. JB, are you trying to say something? Because you're muted.
Let's think about it.
100.
If this quarter is 90 degrees, and this quarter is the exact same size, how much is this worth?
200.
You guys are thinking too much. This quarter is 90. This quarter is also
The same size.
90.
same. 90. So from here to here is 90 degrees. But we're starting at 0. So 1/4 is 90. And then the second quarter is also 90. So when we add those up to get from 0 all the way around to halfway, what's 90 plus 90?
Hawaii.
0 plus 0.
I know 0 plus
0, 0, 0.
And 9 plus 9.
0. 0.
Zero.
Wait, 180? 180?
Yeah.
I knew
So
it.
half of the circle is 180. So that's our other benchmark number. Okay?
I
We're going to
didn't know
keep
that.
going on. Okay, so if this quarter was 90 degrees, And this quarter is 90 degrees. How many do you think this quarter is going to be?
Come on, you got it.
If it's the same exact size.
180.
We're just looking at this section right here. We'll do it in a different direction. How many degrees is this one? If this one's 90, you can say this is 90 degrees. This one is 90 degrees. How much is this one?
90.
Yeah, it's another 90 degrees. So to get from this 0, we're going to go all the way back to the starting point. We're at 90, 180, and we're going to add 90 more degrees. And what do we get? So we have 0 plus 0.
0.
8 plus 9.
17.
Carry the 1. And then 1 plus 1.
2. 270.
Okay, so this benchmark number is 270 degrees. Okay, and then if we were to add, how much more to get back to the starting point? What are we going to add? It's the
We're
same
gonna add
size.
360.
Nope, we're going to add the same. We're just going from here. If these are all the same size, we added 90 plus 90 plus 90. What are we going to add for the last one?
200. No. 90.
Yeah, this section is also 90. So just double check to see if when we go from the starting point all the way back around, we're going to add this last 90 on. And we should get 360. So we have 0 plus 0.
0.
9 plus 7.
16.
And 2 plus 1.
3.
3. Did we
Good job,
get
Marwan.
360 total degrees? Okay, so all we did was chunk this 360 up into smaller 90-degree pieces. Okay, we're going to look at that in a different context now. We're going to use our clock, which we just had up. I'm going to pull it back up. Okay, so what do you notice about this clock?
You get to move it.
Yeah, we can move this around. And we have two different hands. We have the minute hand, which you guys know is the bigger one. And then we have the hour hand. Okay, so all we're going to do is manipulate these hands to show different angles and relate it to degrees in a circle. So what if I move this minute hand? Well, first of all, what are these in terms of geometry lines? Do these minute and hour hands represent a line segment, or a raise? Back to our vocabulary. It has an end point and an arrow. So what is that?
Raise.
Yeah, it's a ray. Perfect. So we have two rays, and we know that angles are formed when any two line segments or rays come together. So I'm going to move one of these rays down so it's on the 3.
It's 3 o'clock.
What type of angle? Well, we're not really talking about the time right now. I just want to know which type of angle I just created. Think back to our vocabulary.
90.
Yep, Marwan, I love your participation right now, but let's have someone else try, okay? Go ahead,
Alicia,
Alicia.
what type of angle is it? Think back to the 3 types of angles. We have acute, right, or obtuse.
Right.
How do you know it's a right?
Because it's 90 degrees.
Yeah, we just talked about that. When we have a starting point and we go 1/4 of the way around a circle, that's a 90-degree turn. Okay, so what if I keep going? So notice I have a different starting point this time. When we were looking at the first example, my starting point was over on the right side. Now the starting point's at the 12. So I'm going to go back now. I'm going to start with both of them facing up. I'm going to turn a quarter turn and then another quarter turn. How many degrees did I just turn my minute hand? Remember, 1 quarter turn is 90 degrees, and I went 2 quarter turns.
Oh, half. Half.
I went half. So how many degrees is that, though?
5. 1, 2, 3, 4, 5.
Remember, guys, if you go 1 quarter turn, it's 90 degrees. And then if you do another turn, it's another 90 degrees. So you have
Yep,
to
so
add
right
those
here,
two.
we did 1 quarter turn, and it's 90 degrees. And then we did 2 quarter turns, which I forgot who just said it. Brian said was half. But how many degrees is that? It's our benchmark angle. I know it's really small.
180. 180.
Yeah, 180. Great. So we know that halfway around a circle is always going to be 180. Right?
What's
So
halfway
what if
around a
I-
circle? What's halfway around a circle?
180 degrees.
Great.
It's always
Kristen,
going to
what's-
be that.
Kristen,
Always, always.
Kristen, you there? What's
Why do you
halfway
think
around
they
a
call
circle?
this half an hour? Because you're moving halfway around. But when we're talking in terms of angle measurements, again, we measure in degrees. So we say it's a 180-degree turn. Okay, what if I start back up here again and I move my minute hands 1 quarter way around, 2 quarter way around, and 3 quarter way around? What is my degree measurement for how much turn I made?
Uh,
I did 1 quarter, 2 quarters, and now I'm doing a third quarter turn.
it's 270.
270. 3 quarter turn will always be 270 degrees. Okay, and then how many turns am I making? If I start here, I go quarter turn, half turn, 3 quarter turn. I did 1 full turn. How many degrees is that? Someone besides Marwan. I did 1 full turn. Faith? Did you raise your hand?
Yes.
How many degrees did I turn for 1 full turn? Remember, how many degrees are in a full circle? I turned a full circle, which is how many degrees? We're going on that last 90-degree turn, and what do we get back to? I know it's not on here, but this is 0 or
360.
yeah, 360. Anytime you make a full turn, you're turning 360 degrees. All right, we're going to look at this in one last context because that's what our target says. It says we can identify and measure angles as turns and recognize them in various contexts. So the first thing we did was just look at a plane circle. Then we looked at a clock to help us understand that each turn is worth a certain amount of angles. Now we're going to use our bodies. So I need everyone to stand back up. Does anyone ever watch like, let me think, like skateboarding or maybe figure skating in like the Olympics? No? Well, sometimes sports use angle turns to tell how many times people have turned. Okay, so what we're gonna do with our bodies, we're gonna stand up. And just like we did on the poster, we can also turn our bodies and represent it as angle degree turns. So I'm gonna start by doing, I want everyone to do it with me, 1 full turn all the way around. Go nice and slow so you don't tip over. So I'm gonna do 1 full turn, and you should be back facing the computer. How many degrees did we just turn?
360 degrees.
Yes, Marlon, 360 degrees. We did a full circle, so we did 360 degrees. I want everyone right now to do a 90-degree turn with their bodies. And I'm going to see where you're facing. So do a 90-degree turn. Okay, so I should, oh, Shalita, you did a full turn. Where am I facing? Marwan, you almost got it. I should see someone's shoulders. Too far, Marwan, go back. Brian, you got it. Faith, you got it. Yep, so Marwan, watch. Facing, we're gonna do a quarter turn. So I should see the side of you. So we turned quarter way around. Okay, come back center. I want everyone to do a 180-degree turn. Go ahead and do a 180-degree turn. What should I be seeing? Yes, Faith. Stop right there. Nope, stay.
Backwards?
Yes, Marwan. Yeah, I should see everyone's back. You're turning halfway around. You turned 180 degrees. Great. Recenter. I want everyone to do, Christian, you doing this? Come on, join us. Up. All right, I want you to do a 270-degree turn. So what does that look like?
Like turning up to here.
180, 270.
Oh.
What do you notice? I see everyone's facing the same way. Well, I'm facing a different way than Marwan. Why is that? And Alicia. Don't move. Just stay where you were. We both turned 3/4 of a turn, but you're facing a different direction than I am. Why is that?
I don't know.
Does it matter which way you turned?
No.
No, you still turned 270 degrees. It just depends. I turned to my right. You must have turned to your left. But you still did a 270-degree turn.
Is it better now?
Well, you weren't wrong. I was just pointing out that it doesn't matter which direction you go in. You're still doing that 270-degree turn. All right, so the key thing here is when measuring angles is to remember those 4 benchmark numbers. We have 0, which, again, that can be any starting point. We have 90 degrees as a benchmark, 180, 270, and 360 is a full turn. Any questions? Nope, all we're doing is doing turns and relating it to angles. Okay, we're mostly gonna focus on these first 2 turns. We're only gonna really focus on from 0 to 180. Okay, the other ones are a little more technical. You'll learn about those in higher grades. So starting later this week, we're gonna talk about just this half of a circle, okay? On your problem set today, it's gonna look like what we did in, share screen here. So your problem set today is exactly what we just talked about. You're gonna tell me how many degrees are in a full circle. Just gonna type it in. Then for over here, you have quarter turn, half turn, 3/4 turn, and 1 full turn. You have to tell me how many degrees is 1/4 turn, and you're gonna drag it up and put it next to the box. So who can tell me right now, how many degrees is 1/4 turn or 1/4 way around the circle?
By the way, I don't have a chat anymore.
Who's got me? How many degrees is a quarter turn?
If you do a quarter turn like this, how many degrees is that?
Brian? Is that your hand or you're just yawning?
180.
Yeah. So a quarter turn, remember we just did this with our body. We turned 1/4 of the way. How many degrees is that? Maron, you gotta unmute yourself.
90 degrees.
Yeah, so you drag that up and place it next to that and do the rest for these. Then on your next pages, it's the same thing. So we have a starting point, and I moved the minute hand. The question's asking how many degrees did the minute hand turn? So if it started at the 12 and it went down to the 3, how many degrees is that?
It's 90 degrees.
How many degrees is that, Faith? If it started at the 12 and it went down to the 3, how many degrees is that? It went a quarter way around the circle. Yep. Miss
Wait,
Terry's making the symbol for it. Straight up,
90
straight out. Yeah, so you type that in,
right angle.
90 degrees. It's also a right angle, but the question is asking us how many degrees. Okay, so you just type in the number there, and then keep going on. Same thing, the minute hand starts up here, and it went halfway around the circle, went from the 12 to the 6. So how many degrees would that be, Shalia? Went halfway around.
It'll be
Think about half.
7.
What's our benchmark for half?
Oh, 270 maybe?
Oh, asking Shalia.
6.
Think about this. From 12 to 3 is 90, and then we added 90 more. Think back to what we got when we added 90 plus 90. Or look at your notes.
$220.
Think about our benchmark numbers. So Shalia, we did this. We started, even though it's a different spot, we started at the 12, which was 0. We went a quarter way, and then another quarter way. And what did we end up with for degrees? 180. Yeah, it doesn't matter if we're on this type of circle or a clock. If we're starting here, this is going to be our 0 point. We went past 90, and our next benchmark is 180. Remember, that will never change whether you're looking at a circle, a clock, a protractor. Anytime you go halfway around a circle, you're getting 180 degrees. Same thing, you're going to enter that in the box, and you keep going. There's only 7 problems. The last 2 are a little bit tricky because I didn't start on the 12. So like for this one, I started on the 9, and I ended on the 3. So how much did I go around the circle? Marwan?
180 or
You got it. Yep. I went around 1/4 and then 1/2. And Marwan remembered that halfway around any circle is 180 degrees. All right. So just think about those benchmark numbers to help you with your problem set.